What's up, guys? Welcome to session 2 of Introduction to Linux Bash Scripting. As always, I am your instructor, Kevin Downs. Today, we're going to be talking about Introduction to Linux Bash Scripting 2, and we're going to be going over shells, pipes, the fish shell, and more, okay? So last session, we went over basic user commands, logging in, logging out, command line editing, navigating the file system, viewing and copying files, and controlling the terminal. Today, we're going to be going over input and output redirection and pipes, command separation and grouping, background extinction, file name expansion, shell variables, command substitution, quoting and escaping meta characters, fish shell features, command execution, and startup files. Let's get started with input and output redirections. So most Unix system commands take input from your terminal and send the resulting output back to the terminal. So this is known as standard input and standard output. A command normally reads its input from the standard input, which happens to be your terminal by default. Similarly, a command normally writes its output to the standard output, which is again your terminal by default. So output redirection, the output from a command normally intended for standard output, can be easily diverted to a file instead. This capability is known as output redirection. So if the notation greater than sign file is appended to any command that normally writes its output to standard output, the output of the command will be written to the file instead of your terminal. So here we can kind of see that. So we have the following example. We have the who command, and real quick, let me actually show you what the who command does. So who, let me log in. So who normally displays this, okay? So if we go back to our PowerPoint here, that standard out of the who command is going to get redirected into the file users. So when we run this, notice that no output appears at the terminal, and this is because the output has been redirected from the default standard output device, the terminal, into the specified file. Let's actually go ahead and do that. So who. Now real quick, when we run ls, we see the only file that exists here is test.txt. So who, I'm going to redirect that to users. Now we see because the users file didn't actually exist, it created that file, right? And if I cat that file, you see it has that output, right? So the output from the who command got redirected to this file, users, and we can see that here. Here's the output of that. So that can be handy, as you can see. A lot of uses for that. Oops. So if a command has its output redirected to a file and the file already contains some data, that data will be lost. Know that, guys. If you redirect output from a command to a file or from a file to another file using the single greater than sign, that data will be lost. So consider the following example. We have echo line 1 and we redirect that to users. Then we cat users. We see we have line 1. Okay. So I'll show you that real quick. Right now, cat users, we have that. So if I do echo line 1 and I redirect that to users, so I have cat users and we still have that same output. Oops, I have a typo here. So I do echo. There we go. Now I spelled it right. Echo line 1. I use the greater than sign to redirect that to users. And now I cat users. Now it just says line 1. So it overrid the info in that file. Okay. Let's go back to our PowerPoint. So to save ourselves from doing that, what we can do is the greater than operator to append the output. Okay. So we look at our example here. We can do echo line 2. Append to users. Then when we cat users, we have line 1 and line 2. I'll show you that. Echo line 2 and append greater than to users. Now when I cat users, you see both lines in there. So put it at the end of this file, right? So also very useful. Let's move on to our next slide there. So as the greater than character is used for output redirection, the less than character is used to redirect the input of a command. So upon execution, we'll receive the following output. You can count the number of lines in the file by redirecting standard input of the word count command from the file users. So we can actually go the other way. We can say send the info from users into the word count command. And it'll give you the count of that, okay? So we can actually flip the way those signs are redirecting stuff. And guys, keep in mind that input and output stuff is going to be covered much more in depth in our intermediate Linux admin course, okay? So we're just briefly going over it here. So we have a document called here. So a here document is used to redirect the input into an interactive shell script or program. The general form for a here document is, we have the command, 2 less than signs, and a delimiter, okay? So delimiter is sent into command, and we have that there. So here the shell interprets the less than operator as an instruction to read input until it finds a line containing the specified delimiter. Okay, you guys, a delimiter could be like a colon, exclamation point. Okay, so it's just going through that file and looking for that specific delimiter that you specified. So all the input lines up to the line containing the delimiter are then fed into the standard input of the command. Okay. The delimiter tells the shell that the here document has completed. Without it, the shell continues to read the input forever. The delimiter must be a single word that does not contain spaces or tabs. So let's go over pipes and filters here. So in this section, we will discuss briefly about pipes and filters in Unix. And then again, guys, pipes and filters will be discussed more in depth in the next course, Intermediate Sysadmin, okay? So you can connect 2 commands together so that the output from one program becomes the input of the next program. 2 or more commands connected in this way form a pipe. To make a pipe, put a vertical bar, and that's located just above your enter key, or should be anyways, on the command line between 2 commands. When a program takes its input from another program, it performs some operation on that input and writes a result to a standard output. It is referred to as a filter. So the grep command is what's commonly used with these pipes, guys. So the grep command searches a file or files for lines that have a certain pattern. And the syntax for grep is grep, the pattern you're looking for, and then the file. So guys, the name grep comes from the ed file editor, which is Unix line editor. It stands for command grep, which means globally search for a regular expression and print all lines containing it. Global regular expression print. Okay? That's where grep comes from, guys. So the simplest use of grep is to look for a pattern consisting of a single word. It can be used in a pipe so that only those lines of the input files containing a given string are sent to the standard output. If you don't give grep a file name to read, it reads its standard input. That's the way all filtered programs work. So we cover more examples of grep later in this course. Okay. But here's some examples. So we do an ls-l and we grep for August. So when we do that, it's going to list all files that have a modified date of August, which we see here. Okay. There are also various options which we can use along with the grep command. We can do -v, which prints all lines that do not match pattern. -n, which prints the matched line and its line number. That can be very helpful. And -i, which prints only the names of files with the matching lines, letter I, or L. Sorry, -L. Okay, I'll show you that very quickly. So if I do an LL, I see all these different files here. Let's do just July here, just this July line. So I can do LL grep July. Okay. So you guys see what happened here is I did the full word July, and this only has JUL. So if I want that to work, I do grep JUL. And let's see if it actually do it lowercase. It won't. And I did that on purpose because I wanted to show you everything in Linux is case sensitive, right? Let me clear my screen so we have some space back. So LL. So I have to do LL grep JUL, just like it's spelled. And then it actually finds it, right? Because that's how it's actually spelled. Okay. I'll show you one more helpful thing here with grep, and that is -I, which means case insensitive. So just give me everything with the letters JUL in it. And there you go. Now it will actually show me JUL. Okay, because I did -I, case insensitive. That's very handy. If you can't, or you aren't sure how something's spelled, you want to throw that -I on there, okay? So the sort command arranges lines of text alphabetically or numerically. The following example sorts the lines in the food file. So we do sort food. And you can see here this is in alphabetical order. Afghani, Bangkok, Big, Isle, okay? Mandalay, sushi, sweet, Tio, okay? So this is the contents of that food file. It may not necessarily be in this order, but since we use sort, it is sorting it by alphabetical order based off the first letter, okay? So more than two commands may be linked up into a pipe. So taking a previous pipe example using grep, we can further sort the files modified in August by the order of size. So the following pipe consists of the commands ls, grep, and sort. So we do an ls-l, and then we grep August, so it's going to list all the files with August in there. We're going to sort it with a +4 in. So the pipe sorts all files in your directory modified in August by order of size and prints them on the terminal screen, okay? So the sort option, +4 in, skips 4 fields. And fields are separated by blanks, and then sorts the lines in numeric order. Okay? So we did an ls-l and sent that into grep, which searched for August, and it sent that into sort, and it sorted it based off the input of these two, okay? So here's some more pipe examples. We can list all files and pipe that into more. And that way we can scroll up and down, okay? We can also do a ls-al, which is all and long listing. And grep that and look for a list of all subdirectories in the current directory. Excuse me. We can also use head and tail to print lines in a particular range in a file. So we can cat the file sample2.txt, pipe that to head to give us the first 7 lines, and then pipe that to tail to give us the last 5 lines of those 7 lines we just did, okay? Here's some more examples. So this PS and WC command pipeline gives you an idea of how many processes are currently running on your system. So you can do PS aux, which is going to list all the processes running on our system. We're going to pipe that to word count, and it's going to give us a line, or it's going to give us back the number of lines on that file. So that could tell us how many processes are running because it'll tell us how many lines there are. We can also use cat, grep, t, and wc command to read the particular entry from user and store it in a file and print line count. So we cat the file result.txt. We grep the phrase rajatx. We pipe that to t file2.txt. We give it a word count. Okay. So it's storing the input from this into the file2.txt. That's going to give us a word count. Okay. So a lot to do there, guys, with pipes and filters. Again, we're just scratching the surface on that. We're going to cover that more in depth later in our courses, okay?